Somewhere in southern Africa, 60,000 years ago, a hunter is crouched by a fire, working a paste onto the tip of an arrow. The plant he's using isn't rare, it grows all over the region. But most people who saw it wouldn't think twice about walking past it. He knows better. One scratch from that arrowhead and an animal many times his size will be dead within minutes. He didn't learn this from a book. There were no books. There was no science, no chemistry lab, no internet to search which plants are poisonous. So how did he know? And how did every human before him figure out which plants would kill you, which ones would heal you, and which ones were just dinner? Turns out humans didn't start from zero. Evolution gave us a head start, and it's still sitting on your tongue right now. We carry a family of about 25 different bitter taste receptor genes. Scientists call them TAS2RS, and they didn't evolve by accident. They evolved specifically to detect plant toxins and trigger one very simple response: spit it out. This isn't a human invention either. The trait is thought to go back over 200 million years, showing up across vertebrates long before anything resembling a human existed. Sweetness told our ancestors, save calories, eat up. Bitterness and sharp sourness told them, proceed with extreme caution. And here's the strange part: that ancient warning system is still active today. It's a big part of why kale, broccoli, and Brussels sprouts taste bitter to a lot of people. They contain faint traces of the same class of compounds that for millions of years meant this could hurt you. Your dislike of vegetables might genuinely be a survival instinct, but taste alone wasn't enough. Bitter doesn't always mean deadly, and plenty of dangerous plants don't taste like much of anything at all. So early humans relied on a second source of information: everyone else in the ecosystem. If a bird ate a berry and flew away fine, if a monkey stripped a plant and kept climbing, that was data. Early humans, and the primates before them, watched what animals safely ate and followed their lead. It's a strategy so effective that some indigenous communities still use it today. It wasn't foolproof. Some animals can safely eat things that would be lethal to a human, the same way a modern dog can get seriously sick from something as ordinary as chocolate. But watching the animals dramatically narrowed the odds, and once that knowledge existed, it didn't disappear. Children learned what their parents ate, generation after generation, the same way primates still teach their young now. Long before writing existed, the forest itself was the textbook. Still, not all of this knowledge came cheap. Sometimes someone ate the wrong thing, and when they did, it would have been unforgettable. Not a footnote, a group-defining event. The kind of moment that gets remembered, retold around a fire, and eventually turned into a rule nobody questions. Over generations, "Don't eat that" stopped being one person's bad memory. It became embedded in oral tradition, in taboo, in the stories elders told children long before they were old enough to test it themselves. And that's the beginning of something much bigger than a survival tip. That's humans turning a single tragedy into knowledge that could save everyone who came after. It's arguably one of the earliest forms of something we'd later call science, which brings us back to that hunter by the fire. In 2023, archaeologists working at the Umlatuzana rock shelter in South Africa uncovered stone arrowheads dating back 60,000 years. When they tested them, they found chemical residue from a plant called Buffon disticha, known locally as gifbol. It's still used by traditional hunters in the region today. This is the oldest confirmed direct evidence of arrow poison ever found. But here's the part that genuinely stopped researchers in their tracks. They compared that 60,000-year-old residue against poisoned arrows held in Swedish museum collections, arrows that were only about 250 years old. The chemical fingerprint was nearly identical. That means this exact knowledge, this specific plant, this specific use, survived, essentially unbroken, for tens of thousands of years. Passed down so precisely that modern chemistry can barely tell the difference. Archaeologist Marlies Lombard from the University of Johannesburg put it simply: This shows early humans understood nature's chemistry well enough to deliberately weaponize it, not just avoid it. And separately, researchers at Cambridge, led by Dr. Valentina Borgia, have developed new, non-destructive ways to test ancient tools for poison residue, pushing the likely origin of plant-based hunting poison back to at least 30,000 years, with hints it may stretch back even further than that. Somewhere in southern Africa, 60,000 years ago, a hunter is crouched by a fire, working a paste onto the tip of an arrow. The plant he's using isn't rare, it grows all over the region. But most people who saw it wouldn't think twice about walking past it. He knows better. One scratch from that arrowhead and an animal many times his size will be dead within minutes. He didn't learn this from a book. There were no books. There was no science, no chemistry lab, no internet to search which plants are poisonous. So how did he know? And how did every human before him figure out which plants would kill you, which ones would heal you, and which ones were just dinner?